Hello and welcome to watch this video about JavaScript Node.js programming. In this video we are going to study inheritance, which is a very essential concept in object-oriented programming. And you will see that how inheritance is done in JavaScript. We are going to do this by first studying a program called Animals.js. And in this program, a simple class named Animal is defined, and then we are going to make a new class based on this Animal class. We will study keywords like extends and super, and we will learn what are superclasses and subclasses, and what are base classes and derived classes, and also we are going to use method overriding in this video. Well, my name is Kari Laitinen, and let's then start studying. So you can find this Animals.js program if you first go to naturalprogramming.com and then you select this JavaScript icon, and you will find this page, and in this list there is Animals.js there, and you can download it with the right mouse button. I have already downloaded the file and I have it open in the editor here, and it looks like this. And let's first run the program. So I can run it by typing node and the name of the file, and the program says simply, hello, I am a cat. I have eaten fish, chicken. Hello, I am a vegetarian dog. I have eaten salad, potatoes. Hello, I am a cat. I have eaten fish, chicken, milk. So these are animal objects here speaking. So in this file there is first this class definition, class animal, and later on in the file there is the main program in which animal objects are created with a new operator. So here we create two objects and these names are cat object and dog object, and we create an animal object like giving a species name as a parameter. So there is a cat and there is a vegetarian dog, and then here we feed the objects with a feed method, and the name or the food for the animal is always a string, and then these strings go to the stomach of the animal. And well, we could test this program if I would write here like cat object and make speak. If I would make it speak before I'm fed the animals, you will see that it says here that I have eaten and there is nothing listed there. So the animal object always says, when it's made to speak, it always says what it has eaten. So, well, I can take this away from now. So now we have the original version of the program, and so here we feed both the cat object and the dog object with these strings, and then we create another cat so that we give a cat object as a parameter. and then we feed the other cat with the feed method and give it the milk, and then in the end we make all the animal objects speak by calling the make speak method, and this then produces these text lines to the screen. So this is basically how we can use the class, the animal class. And let's take a look at what is inside the class definition. So here we have the constructor that is called when an object is created with a new operator, and then we give a parameter. We always give a parameter for the constructor, but the problem here is that it is not known what is the type of the parameter. So because in some cases we give a string as a parameter, or in most cases we give a string, and then but in here we give another animal object as a parameter. So the constructor must then check that what is the type of the given parameter. So here it is first checks that if it is a string. If it is a string, then it just supposes that the given parameters is the species name, and then it creates a data field for the species name, and it also creates a data field for the stomach contents, and it says at the beginning the stomach contents is an empty string. But if the given parameter is of type animal, then we suppose here that another animal object is given as a parameter, and then we just copy the data fields from the other object. So this is kind of copy constructor or copy operation, so that we can copy an animal and we create the new data fields, species name and stomach contents here when we write this word this. And it also informs the user if the parameters are not acceptable. So then this line is printed. Because there can be two types of strings in JavaScript. The testing that if the parameter is of type string, we have to use both the type of operator and the instance of operator here. And well, this handles the case when the given parameter is a string object. So this is the constructor that builds an object. And then we have two methods. There is the feed method and there is the make speak method. And the feed method gets a food string as a parameter. And then this parameter is just joined with a plus operator to the end of the current stomach contents. And then we add a comma there, so comma and a space there, so that the food inside the stomach of an animal is then separated with commas, as you can see here. And this other method, make speak, it just prints this line. It says that what is the species name and what the animal has eaten. And you should note that we always have to use this word this when we refer to the data fields or attributes of the inside that are inside the object. So you can think that animal objects are such that they have two data fields, stomach contents and species name. And each animal object has its own data fields, these two data fields. So this is basically the current version of this program. There's a simple class and then we use the class to create objects. And now we are going to modify this program, and we are going to use inheritance to make a new class of this class animal. And we can write the new class. So here ends the class animal, so we can write the new class here, and we use the keyword class to specify the class, and let's make this a singing animal. And when we want to, so normally a class looks like this, that we have the class name and then we have a pair of braces, and inside the braces we specify what the class is like. But when we want to use inheritance, we write here the keyword extends and we write another class name. So this means now that this class SingingAnimal inherits the class animal. And here we can specify what this new class adds, or how the new class extends the existing class. But if we do it like this, nothing happens. So that we can do so that we can, if I modify this now, I create the object, this cat object, so that I use the type or the name SingingAnimal, so we can see what happens. So I will save it and let's rerun the program. So we can see that nothing changes. So we can see that now, although this cat object is now of type SingingAnimal, it behaves exactly like it were an animal object. But for instance, if I would change, or let's make a change here. So let's add a new method to this class. Let's add a new method here. So then the SingingAnimal will be a little bit different. So I will make a copy of this make speak, and I will copy it and I will paste it here. I will change the name to make sing. And let's modify this a little bit so that like this. So when this method is called, this text will be printed to the screen, and the text says that what is a species name, and it says that what is that the animal is singing. So I have to call this method Now I'm calling this new method. And let's see what happens. So it says, as we specified in the method, hello, I am a cat, I am singing now. So we can see that the new method works for this object of type SingingAnimal. But let's see again that if we would put here if I would write here dog object, and try to make that object sing, it now says that type error. It says that dog object dot make sing is not a function. So the reason for this is now that because now dog object refers to an object of type animal, and in the animal class we don't have this make sing method. So it will result in an error, but in the case of cat object it was possible to call the method. But if I modify this program again so that I will use the type SingingAnimal here, this should work. Let's see. I will save it and I will rerun the program. So here you can see that also the vegetarian dog can sing now, because it is now of type SingingAnimal. So, so our both objects are now of type SingingAnimal, and we have a new method make sing there. And let's do another method. Let's make it so that let's now do some method overriding here. So we can, let's make a copy of this method make speak, and let's copy it. So now this SingingAnimal class has two methods, make sing and make speak, and the make speak is now the same. It has now the same name as the corresponding method in the upper class. But we can add here something. Let's add here something. Sorry about this. Take this out from here and add new line to the end. Now this make speak should then cause a new line pre-printed in case when the animal is type SingingAnimal. So let's test the thing. Well, we can just save save the file and rerun the program. Now you can see that in case of the cat object and in case of the dog object, this extra line, I am a singing animal, was printed to the screen. But in the case of this another cat object, and because this is still of type animal, it uses just the old printing there. So we can see now that this, for SingingAnimal objects, there's a different version for this same method called makeSpeak. And we say that so when we write a new method with the same name into a derived class, we say that we override the method that would normally be inherited from the upper class. So we can say that we can also list these terms now. We can say that we speak about class hierarchy, and some classes are higher and some are lower in class hierarchies, and so we can say that animal is here in upper class or higher class, and SingingAnimal is a lower class. Or we can say that animal is a superclass and SingingAnimal is a subclass. These terms are also in use. Or we can say that animal is a base class, SingingAnimal is a derived class. So there are many names for these. Many names that are used for the classes when inheritance takes place. So now we have this class such that there are two methods. The other method overrides the corresponding upper class method. And let's then think about these constructors, because we don't have a constructor here at all. But it is so that when you don't write a constructor to a derived class, we can think that the execution environment for the program automatically creates a constructor that uses the upper class constructor, so that in this case a constructor like this because in JavaScript there is this possibility that you can call the constructor of the superclass with this keyword super, like this. But in the normal case that if we don't write a constructor to a derived class, the compiler or the system that executes the program, it automatically creates a constructor like this, that it passes the parameter to the superclass constructor. So for this reason, we didn't need to write a constructor to this class. But in case when we would like to construct or create the derived class objects in different way, we might need to give more parameters. So in that case, we need to create an own constructor or new constructor, and then, for instance, let's suppose that we want to give a song as a parameter for this singing animal, so that each singing animal will have an own song that it's going to sing when it is made to sing. So let's try this. I will first save this and test that it still works. It works still. I added this new constructor here, but it didn't affect anything there. But if we would like to have another parameter here, like given song, and then we would use this new parameter so that we would create a new data field there would be a new data field inside the SingingAnimal class named song to sing, and we will store this given song, the second parameter, to that data field. And then if we modify this program like this, we have to, when we create the SingingAnimal objects, we have to give some value to this parameter. So let's modify this, that when the cat object is created, we give a song like and a dog object might sing like maybe these are good songs for these animals. So let's save the file and test it. Well, it still runs, but nothing has changed because we are not using this extra new parameter here, or the new data field, but we can modify this make sing method so that it shows this song to sing data field. So let's do that. I will write here and use the plus operator here, and this with this keyword I refer to the new data field. Now it's the make sing method should say that what is a song that the object is singing. Okay, I will save it, rerun the program, and now the vegetarian dog is singing woo like this, because the reason for this is that we gave a parameter, this parameter, then when we created the object. And if I would make the cat object sing, it uses then this string that was given when the cat object was created. So this is how we can make a constructor for the lower class or derived class. So we can call the superclass constructor to process the one parameter, and then we can do something with the second parameter. Of course, it would also be possible that we would do something here, something different here for the first parameter. Normally, if the same parameters are also good for the lower class, then we don't need to write a new constructor. Okay, let's then make one more modification to this program. So when you study these two classes, you can see that in both classes there is this make_speak method. These methods, they are almost the same, but then this other make_speak method prints this extra line. So we could modify this so that because now this statement is the same in both methods, we can modify this now so that this doesn't. So we can simplify this make_speak method of the derived class so that we can call the corresponding method in the superclass, and we can do it in this way that I will replace this statement by writing super and make_speak. When I do it like this makes a method named make_speak first calls this other make_speak, and then it prints this extra line of text. Let's see how this works in practice. I'll save the thing and let's rerun the program. And now it works in the same way as before. So for the object of type SingingAnimal, this extra line is printed to the screen, but when we use the normal animal object, no extra line is printed. So maybe I think that these are the most essential things in object-oriented programming. So when you create a new class and you want to use inheritance, use this keyword extends, and then you can write a new constructor for the derived class. You can add new data fields or attributes to the derived class objects, and you can override a method, or you can add new methods, and you can call a superclass method with the keyword super and the dot operator. Well, I think these were the most important things in object-oriented programming. We covered all these topics that were listed here. So I hope you enjoyed this video, and it doesn't harm you at all if you watch this video many times. So I thank you and meet you in next video. Bye bye.